In this video, we're going to look at using Prim's algorithm to find the minimum spanning tree, but we're going to not have a graph or network visually drawn out and just working our way through that. In this instance, we're going to have a distance matrix. So the idea is that matrix lists all the nodes twice, one down the left for the rows, across the top for the columns, and for each connection that exists, the cost, the value, the weight is listed out. Okay, there are no loops. We're not interested in loops anyway. With a minimum spanning tree, we don't want any sort of cycles, what have you. So you see that A, B, B, C, C, and so on. So there's just blank. Not even bothering to put zeros in there. So how can we work our way through with Prim's algorithm? Just very quickly, just before I actually start, this matrix, you'll notice, is symmetrical. There's no directions. There's no situation where cost in one direction is cheaper than the other direction. So there's a symmetry about this matrix. If I were to draw a network, it might look like that. Every single node is connected to every other node, and I've drawn on the weight. So that's the sort of the network that you'd be working with if you're doing it visually. So that's the representation in a matrix form. So if you remember, with Prim's algorithm, we chose any node to start off with, and then from that node we were choosing the arc, the edge that was the cheapest to any other node that was not already selected. And then once you have more than one, you're having to consider all of the nodes that you have selected so far and checking to see what remaining arcs are possible from them. And the key thing is, as usual, you do not want to create a cycle. So let's pick a node at random. So let's choose, I don't know, let's go with B. So I'll select B, and the first thing I do once I've selected B is I'm going to basically delete all the values from that row, and then I'm going to label that node up the top as the first one I've selected. Okay, so you looking at that column, which value is the least value? So looking down column B, I can see 2, 3, 5, 3. 2 is the cheapest, the smallest value. So let's just select that. That connects up with A. So we're going to connect up B with A at a cost of 2. So now I've selected A, I'm now going to delete all the remaining values in that row. And I'm going to label my new node, the column for it, number 2. Okay, so I've now selected node A as well as node B. I have both those two selected. You can see the numbers above just showing that I've got those. Now, if you want, you can do a bit of color. You could actually sort of select them as well. Okay, with a bit of color if you wanted to. To be honest with you, the bit of color I had over that B wasn't really of importance. So I've got A and B both selected with a connection of 2. So I now need to look down both those two columns. So I'm looking down both the column for A that isn't crossed off. So you can see 4, 5, 6, and down B, 3, 5, and 3. So the cheapest weight is 3. Now, eeny, meeny, miny, mo. It doesn't matter now at this point in time which one I go with. And this is the example I said to you where you may have a situation where you have more than one possible minimum spanning tree when you have weights that are the same, and you get that moment, that sliding door moment where you choose one or the other. It doesn't matter. So eeny, meeny, miny, mo. I'm going to go with E just for the hell of it. So I'm going to select E, that cost of 3, and then I'm going to say, right, I've selected E, and I'm going to cross off the remaining values in that row. So I now have A, B, and E. Okay, so now looking at A, B, and E, so I have to look down the rows. So I've got the 4 and the 5, and the 3 and the 5, and the 5 and the 2. Okay, so I'm not looking at C and D. So looking at A, B, the remaining values, and E, I can see that that 2 is the cheapest weight. That connects up with D, so I can cross off the remaining values for D and select that as my 4th node. And so lastly, all I have to connect up is with C. So 4 and 3 and 7 and 5. The cheapest cost I have here is the 3. That connects up C. And I can label that at number 5. So I have my solution. So I have B connects up with A, C, and E. And I have E connects up with D. The total cost, if I add it all up, so from B to A, I've got a value of 2. From B to C, I've got a value of 3. From B to E, I've got a value of 3. And from E to D, I've got a value of 2. And I add that up and I get a total cost of 10. You'll notice that the crossing off, okay, of a row will help to ensure that you do not create a cycle, because you're avoiding the scenario where you're trying to connect back up to a node that has already been selected. And if you want to visualize what that minimum spanning tree would look like, okay, you've got A, B, and C connects up, E connects up to B, and then from E we've got connects up with D. In the last example we had, you notice that every single node was connected up with every other node. Here, this is an example where we don't have every node connected. You can, notwithstanding the diagonal down the middle, you see there are other nodes that are connected, so U and V are not connected up at all. Yes, you can see there's symmetry through the diagonal from one half to the other. So again, systematic, we start off with one at a time. We pick any starting point. It's completely up to you. And what you might want to do is, when you do one of these questions, you might decide to try it where you start from a different, do the question twice and actually start with a different starting point, and you should find that you get pretty much the same answer. Okay, so let's pick a, I don't know, where should we go with? Let's go with, I don't know, X. You know what, our math teachers, we like the letter X. So let's start with X. Okay, so we're going to select X, and we're going to, I don't know why I'm highlighting it, but just it makes it easier to see the columns. So that's the first one. So right, let's just completely cut out X. Okay, so from X, what is the cheapest arc edge? That's to V. So we're going to select V. So cross off the rest of V and select V as the second one. Okay, so we've got X and V that we're now looking at. So I'm now going to be looking down the X and V columns, and I'm wanting to look for a value that hasn't been crossed off and hasn't already been selected. So the 5 has already been selected. So 6, 8, and 6. 6, I'm ignoring that 5, 7, and 8. So it seems to be 6 is the smallest number. I've got a choice of 3 different numbers. I've got 6 here, V to T. I've got 6 here, X to U. And I've got the 6 here, X to Y. This is where you will sometimes have a situation where you could end up with a different minimum spanning tree than somebody else. It doesn't necessarily matter. You just have to choose one. Okay, so I'll tell you what, we'll go with the first one there we see here, V to T. So we'll select that one. I cross off everything else in the T row. I'm selecting T as my third node. So now I have X, V, and T to be looking at as columns. So I have still to connect up with U, W, X, and Z. So I've got 6 and 8 and 6. I've got 7 and 8. And I've got 5, 8, and 4. So 4 is the smallest value I was looking at there. So that's connecting up with Y. So cross that off. That's going to be my fourth node that I'm connecting to. So I'm now concentrating on the T, V, X, and Y columns. And again, so systematically, I'll work my way through. I've got 5 and I've got 8. I've got 8. I've got 6 and 8. And I've got 6. So thinking about that. And sometimes when you do this, it's worth your while just only keeping the smallest number you've got to so far. So starting with 5. Okay, that's not less than 5. 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 So 5 is the lowest value. Oh, wrong pen. And I'll cross off U, select U as my fifth node that I'm actually interested in. And then I'm saying to myself, right now I'm looking at T, U, V, X, and Y columns. So what number is smallest? So 8. Okay, 7 is smaller, so I'll go with 7 now. As a running total, which one's the smallest number? Okay, 6. So 6 is the smallest number. Go down the V column. 8. No, that's not smaller. So 6, 6, 6 still. 8. No, 8's not smaller. And Y. Okay, so I've got another 6. So I've got two 6s there. I've got U connected up with Z, and I've got Y connected up with Z. It does not matter which one I go with. I'm going to go with the first one I came across, which is the that 6 there. I could have gone with the other 6. It doesn't make any difference. Okay, but I've now got Z connected. So that's my 6th node connected. And now I'm looking at effectively which one is the cheapest one connecting up with W. So I'm looking down T, 8, 7, that's smaller. No, that's blank. 8, that's not smaller. That's blank. Z, that's 7. Okay, so 7, I've either got the U connects up with W, or I've got Z connects up with W. Again, it makes no difference. I'm going to go with the first one I found, and that is that one there. So I can now cross off W. I can say I've selected now as my 7th node with the value of 7. So I've got 1, 2, 3, 4, 5, 6 values. So again, remember, if I've got 7 nodes, I'm going to have 6 edges, one less. Okay, and if I then sit there and add them all up, so 6 and 5 and 5 and 7 and 4 and 6. Okay, I add those up. I'm going to get 22, 33, I believe. Now, the only thing I'm being a little bit naughty is arguably you should actually sort of list them out, okay, in the order. So almost as you go along, arguably you can list them out. So arguably what I should have been doing is list them as I select them. I write out what that arc that I've actually in order. So, and the reason for that is it just helps to show from an examination perspective that the sort of the order of the process that you went through. But anyway, the cost is 33. Okay, so ramping this up a little bit, so even more complicated. Just getting it's getting bigger. It's getting more complicated. If you imagine me drawing that diagram, it's just going to be just a bit more difficult. You know, if you imagine a 9-sided shape, all with diagonals across, it's just a hassle. So this is where the matrix begins to be more useful. So owners of a hotel wish to promote their hotel in new Asian markets. To do this, they produce a special brochure. At the moment, the brochure is only available in English. The table shows the cost of translation for the brochure between all of the various different languages, including English. use Prim's algorithm on this table, i.e. this distance matrix, to find a minimum spanning tree and thus find the minimum total price for having the brochure translated into all languages. So what they're saying is, it may not be cheapest to go from English to Cantonese, English to Indonesian, English to Japanese, English to Korean, English to Lao, English to Mandarin, English to Thai, English to Vietnamese. It might be easier, right? Okay, well, English to Cantonese, and all of a sudden, right? Okay, Cantonese to Mandarin is actually cheaper, and you tick that box, in a cheaper process. So let's find the cheapest way of connecting up all these languages, assuming you have the translators available to you. I'm going to use a slightly larger diagram than that. So let's just scroll down. There you go. It's a slightly larger version. And let's see if we can work our way through. So we might as well, since we have it in English, we might as well start with English. Okay, no particular reason. We don't have to start with English, but I'm just logically, it probably feels, it makes more sense. So let's just cross off English. That is where we are starting. So 1. So what is the cheapest language that we can convert it to from English? So we have Korean as the cheapest value. Okay, so from English to Korean, the value of 450. So I'm going to start having difficulties. English to Korean. I'm just going to do it in tens. So Korean is going to be now crossed off to avoid any cycles. So Korean is the second one I'm choosing. Okay, so English and Korean are the two columns I'm now looking at. I'm not looking at any others. So looking down the English column, 500, 650, no, 500, 500, 500. Okay, Mandarin is cheaper, 480, 480, 480. 480, 480, 480, 480, 480, 4. So nothing is cheaper than 480. So let's select that. So Mandarin is the third language we're going to choose. So English to Mandarin, the cost of 480. So let's cross off that row. So now I have 3 selected. I'm now going to be looking through. So 500, 500, 500, 500, 500. Looking for something less than 500. Okay, here we have one there, 350, 350, 350, 350. So 350 is the cheapest option. Cantonese from Mandarin. So we've got the Mandarin to Cantonese at the cost of 35. So let's cross that off. And that's going to be our 4th language that we choose. So now I'm looking at 4 columns. So 650, 650, 650. Okay, 540, 540, 540, 460. So again, as you see, all I'm doing is in my head, I'm just calling out the number that I've got in my head. That's the cheapest value I've got so far. 460, 460, 430. Okay, 430, 430, 430, 430, 430, 430, 430. I'm only going down the columns that I have selected. 430, 410. So 410 is the cheapest value I've got there. So Mandarin into Thai at 410. So I cross off the Thai row, add Thai to my list. That's 5. Now 5 languages I have selected. So again, 650, 650, 620, 460, 460, 460, 460, 460, 390. So 390 is the cheapest value I found there. So that's with Indonesian. So that's Thai to Indonesian at a cost of 390. So I need to now add that to, so I now have 6 languages connected up. So I've still got to connect up Japanese, Lao, and Vietnamese. Right, okay, so again, so working systematically through with ones that have not been crossed off and have not already been selected. So 700, 700, 620, 620, 490, 490, 490, 490, 440. Okay, so 440 is my cheapest value running so far. And 440, 440, 440, 440, 440, 440, 440 seems to be my cheapest value so far. So it's Vietnamese from Indonesian. And I include now Vietnamese in my list. So I've now selected my 7th language. So now I have to go through all 7 columns and find, obviously I'm getting less values to have to actually check because I'm crossing lots of them off. So I've got 700, 700, 670, 490, 490, 490, 490, 490, 490, 490, 490, 490, 420. So Vietnamese to Lao is the cheapest. Vietnamese, oh hang on a second, I'm wrong. Vietnamese to Lao is 420. So cross off Lao, add that to my list as my 8th language. And now lastly, I've just got to work out which is the cheapest language I can connect from into Japanese. So Japanese, so 670, 670, 600, 600, 600, 600. So 600 is the cheapest value there. Japanese from Korean. Okay, at the cost of 600. So I cross that off. And I add that off as my 9th node. So I had 9 nodes. I now have them all selected, and I have that selected using 8 different edges. So if I count, I notice 1, 2, 3, 4, 5, 6, 7, 8. I've got 8. 1, 2, 3, 4, 5, 6, 7, 8 down my column. So I know through checks and balances, I have all my 9 nodes connected with one less, i.e. 8 edges, and the costs of them are there. And all I now need to do is my final 9th step is to add up those values, and I get a value of, I seem to have 3,540 as my total cost. So that's the process of using a distance matrix to be able to find the minimum spanning tree using Prim's algorithm. The key thing is you're making sure you don't have any cycles. This process of crossing off the rows as it go along is a way of ensuring that you don't get any cycles. You work systematically numbering each column. You're only checking the columns that you've selected so far. That's probably the hardest bit about it, making sure which columns you've got to check. And you're just looking for the least value that hasn't already been selected and hasn't already been crossed off from the rows that you have, so from the columns that you have sort of selected so far. So have a go at the remainder of exercise 11H. So that's basically some from 5 on 5, 6, and 8, 9, and 10.